morning my dear students and welcome to Big Data Analytics class. Yes, in today's class we are going to learn about Hive architecture, components of Hive architecture and various data types of the Hive. So this is the Hive architecture and which is very important. So in the Hive architecture we can see 4 phases. One is a Hive client, another is Hive services, another is called as processing frameworks resource management, and last is called as distributed storage. So these are the 4 phases present in the Hive architecture. And among the 4 phases, the first 2 phases are very important in the Hive architecture. So what is the first phase is that is called as a Hive client. So what the Hive client will do is, the Hive client will interact with the clients with the help of the thrift applications. So thrift applications are nothing but some important applications which are designed to meet the purpose of the Hive. So the Hive clients are going to be interacted by the thrift applications, and we have JDBC applications. So this is thrift application is one way. Another way is JDBC applications where you are going to write the Java programs. That means that in Hive, as in our previous sessions we have discussed that the Hive query language makes use of writing the queries. Similarly, we can make use of JDBC, that is called as Java database connectivity. That is nothing but Java database connectivity we call as a. So we are going to write Java database connectivity applications, and to do that we are going to make use of Hive JDBC drivers. That means you are going to use these drivers. And we have ODBC. ODBC stands for Open Database Connectivity. Open Database Connectivity. So ODBC applications makes use of Hive ODBC drivers. That means the Hive client works in 3 different fashions, that is called as a thrift application is one, JDBC application is one, and ODBC application is one. So default mechanism is, this is the default mechanism, but remaining that is called as JDBC applications and ODBC applications, they are not default, we need to install them to make use of it. So that is the first phase of Hive client. So where you can see the thrift applications, JDBC applications and ODBC applications. And the next important phase is nothing but Hive services. What is this Hive services? The Hive services basically works for the Hive providing the services. So this is your default database. Derby is your default database for the Hive. Apache Derby we called as that is a default database. So Hive web interface will make a connection with Hive servers, Hive drivers and Metastore, and this is called as a client command line interface we call as a, and command line interface where you type the commands and it makes connection to the Hive drivers. If you are not using the command line interface and if you are using the Hive interface or CLI, that is called the command line interface, ultimately it will comes to the Hive drivers. But only difference is nothing but if you are well versed with the command line interface, you can go with the CLI, or if you are not aware of the CLI mode perfectly, then you can make use of Hive web interface. But whatever it could be, it is going to connect to the Hive servers and to the Metastore, and the Metastore keeps all the meta information in the default database that is called as the Apache Derby database, which is basically available in the Hive when you install the Hive in the Cloudera. Right. So these are the 2 important phases, that is called as the Hive client and Hive services. Next, coming to the third phase, that is called as processing framework resource management. So what is happening with the processing framework resource management is, The core principle of the Hadoop architecture is nothing but, even though you write the PIC script or even though you write the Hive query language, internally everything will be converted in the form of map reduce coding only. So that is what happening in the third phase, that is called as processing framework resource management by using the map reduce version 1, version 2 or TASE we call as a YAN. So all these things will be used for processing the framework of resource management, and all these things are going to be stored in the HDFS, that is called as a Hadoop distributed file system. That means the Hive, you can directly work on the database data present in the HDFS directly from the HDFS also. So these are the 4 phases of the Hive architecture. These 2 architectures are, you are not much worried about that, but the first 2 are very, very important here. The Hive client can be interacted by the thrift applications or by the JDBC applications or by the ODBC applications. So when you are making use of thrift applications, it is going to interact with the Hive thrift client. If you are making use of JDBC application, it makes use of Hive JDBC drivers, and if you are making use of ODBC application, it makes use of Hive ODBC drivers. But Hive thrift client, Hive JDBC driver and Hive ODBC driver, all 3 will connect to the Hive server only. I repeat it once again, Hive thrift client, Hive JDBC driver, Hive ODBC driver will connect to the Hive server only. Similarly, the Hive web interface and CLI will connect to the one driver only, that is called as a Hive driver. If you are well versed with the command line interface, you are going to make use of CLI. If you are well versed with the Hive web interface, you are going to make use of Hive drivers. And ultimately the Metastore will be stored in the Apache Derby, that is called as a database, we call as a. And the third phase we call as a processing framework phase, or we call as a resource management. So whatever the operations performed by the Hive query language, internally they are going to be converted in the form of map reduce coding. And the last phase, that is called as a storage phase or distributed storage phase, which is nothing but HDFS, Hadoop distributed file system. Hive or Hive query language can work with the HDFS data directly. So these are the 4 important phases of the Hive architecture. Among the 4 phases of the Hive architecture, these 2 phases are very, very important phases, because the entire processing is done by the Hive servers and Hive drivers. Metastore, which is connected to the database, the default database is Derby, but you can make use of any database, that is called as Oracle or any database, but by default database of the Hive is Derby database. So this is all about the Hive architecture with the diagram we have seen. In detail we are going to see Hive architecture. So that is nothing but, we have made, for better understanding, we have made the Hive architecture into different components. So what are the important components are? Hive client is one important component, nothing but Hive supports applications written in many languages like Java, C++, Python, etc. And they can make use of JDBC, ODBC or thrift drivers, because unless and until you don't use these drivers, you cannot connect to the Java, you cannot connect to the C++. So people who are having a already knowledge of JDBC, ODBC connection when you are writing the Java program, they will be having a very good understanding why there is a need of drivers. Hive client application can be written in language of their choice. That means whatever the programming language you want to use, its choice is purely based on the user's choice. Hive services is nothing but Apache Hive provides various services like CLI, web services, etc., web interface, etc., to perform the queries. If you are well versed with the commands, you can make use of CLI. If you are well versed with the web interface, you can make use of web interface, but ultimately you have to work with the Hive drivers. As the diagram shows, you have to work with the Hive drivers. So that is about the Hive services. The next is called as processing framework and resource management. Internally, Hive uses Hadoop MapReduce framework as de facto engine. This is called as a de facto engine. So where the conversion things happens. That means all the Hive query language will be converted in the form of MapReduce. That mechanism we call as a de facto standard, as a de facto engine to execute the queries. And the last component of the Hive architecture is called as a database, is called as a distributed storage. As Hive is installed on the top of the Hadoop, it uses underlining HDFS for distributed storage. So as the Hive is installed at the top of the Hadoop, and you can make use of HDFS data to perform the queries using the Hive query language. So these are the 4 important components of the Hive which we have seen through the Hive architecture too. So among that, 2 major important components are very important, which we are, it is necessary to learn more about it in depth aspect. So what is that is Hive client. Apache Hive supports different types of client applications for performing queries on the Hive, and these client applications can be categorized into 3 types. These client applications can be categorized into 3 types, that is called as a threat application, JDBC clients and ODBC clients. So threat clients are nothing but Hive server is based on Apache threat. It can serve the requests from all those programming language that supports threat. And JDBC client, Hive allows Java applications to connect using the JDBC drivers. So Java applications makes use of JDBC drivers, and it makes use of the package called as org.apache.hadoop.hive.jdbc.hive drivers. And the third category of the client is called as a ODBC client. The Hive ODBC driver allows applications which supports the ODBC protocol to connect to Hive. So JDBC driver and ODBC driver uses the threat to communicate with the Hive servers. So these are the 3 different clients which we have already discussed in the Hive architecture. So let's see about the Hive services. Hive provides many services. So let us have a look on each of them one by one and its importance also. One is called as a command line interface. So that is a default shell provided by the Hive, where you can execute Hive queries and commands directly. That means it is a shell will be provided for you, and you can write the commands and you can execute the commands if you are well versed with the command lines. The next service is called as a web interface service. So apart from the command line interface, Hive is also providing the web interface for executing the Hive queries and the commands. The next service is called as a Hive server. What is a Hive server? Hive server is built on the Apache threat. So therefore it is also referred as a threat server. So since Hive server is built on the Apache threat, therefore it is called as a threat server also, and that allows different clients to submit requests to Hive and retrieve the final results. So these are the 3 important services of the Hive, that is called as Hive command line interface, Apache web interface and Hive servers. So we have a drivers also here, Apache Hive drivers here. Let us see what is the duty of the Hive drivers. So it is responsible for receiving the queries submitted through CLI, that is called as a command line interface, and web interface, threat or ODBC or JDBC interface by a client. At that time, what is going to happen is driver passes the query to the compiler. Driver passes the query to the compilers, where parsing, type checking, semantic analysis takes place by using the schema present in the Metastore. So already in the Hive architecture we have seen the Metastore. So that only we are describing in a detail. So what is going to happen? The driver passes the query to the compiler. When the driver passes the query to the compiler, then parsing, type checking, semantic analysis takes place by using the schema, and the schemas are stored in the Metastore, right. In the next step, an optimized logic plan is generated in the form of a DAG. That means, if you remembered, in the pig architecture also the same steps has been used in the architecture. In the next step, the optimized logical plan is going to be executed in the form of a directed acyclic graph of map-reduced tasks and HDFS tasks. At last, finally, the execution engine executes these tasks in order of their dependency using the Hadoop. So, these are the roles and duties of the Hive drivers. Let us discuss about Metastore. Metastore is nothing but it is a central repository for storing all the Hive meta information, and it is very important because it keeps all the centrally located storage area where all the meta information is stored. And if meta information is stored, then it is very difficult to do the job. So, Hive metadata includes various types of informations such as structure of tables. That is why it is very important, as I said you, structure of tables, partitions along with the columns, column type, serializer, deserializer, which are required. The serializer, deserializer are required to perform the read-write operations which is present on the data which is present on the HDFS. The Metastore basically consists of two fundamental units. What are the two fundamental units is a service which provides Metastore access to other HDFS services, disk storage for metadata which is separated from the HDFS storage. So, these are the fundamental services or units of the Metastore. So, I repeat it again, Metastore is very important as it is a central repository for storing all the Hive metadata information, and Hive metadata includes various types of information such as structure of tables, partitions along with the columns, column type, serializer and deserializers which are required for the reading and writing operations on the data, and the data is present on the HDFS. And the Metastore basically consists of two units. The first unit is called as a service which provides Metastore access to other Hive services. And second important fundamental unit is disk storage for the metadata which is separate from HDFS storage. So, that is about the Hive architecture and important components of the Hive architecture. Now, let us go with the data types present in the Hive. So, these are the important data types. The data types of the Hive has been classified as two categories, that is called as a simple data types and composite data types. What is a simple data types are nothing but Boolean type which stores the true or false values. Integers, it has four categories, that is called as tiny int, small int and big int. The tiny int size is 1 byte integer, small int size is 2 byte integer, and int is 4 byte integer, big int is size is 8 byte integer. And the other type is called as a floating point numbers, that is called as a float, which is single precision value, and double is a double precision value. And the last primitive type is called as a string type, that is called as a sequence of characters. So, these are the four different types of the Hive data types which are called as a primitive types. The next type is called as a complex types. What are the complex types is, complex types are built on the primitive types. So, already in the previous slide we have seen the primitive types. The primitive types we have seen as integers, small int, big int, double values, precision values, all those things. So, what is a complex types is, complex types can be built on primitive types and other composite types using the following three operators, that is called as a structs, maps and arrays. So, let us see structs. It can be accessed by using the dot notation which you have learned in the C language. Maps, key value tuples, all the map reduce programming also we have learned by using the key value tuples which can be accessed by using the element and the notation. and arrays are indexable lists. Elements can be accessed using the index, that is called the n notation, where n is nothing but index, and wherever the location is there, the location is going to be specified by the notation n value. So these are called as a complex types. So I repeat it, struct is one complex type, map is one complex type, arrays is one complex type, and these three complex types are built upon the primitive types. And we are going to use these data types for writing our Hive query languages and programming. So thank you so much for listening the class, and in today's class we have discussed about the Hive architecture and its importance and its role. We have discussed about the Hive components and how the Hive servers worked, how the Metastore importance is there, and we have discussed about the Hive data types. Thank you so much for listening the class, and in next class we will meet with the new topic. Thank you so much.